Hi friends, my name is Maruti and I'm the co-founder of Cracku. In this video, we'll be looking at the LRDI solutions for Slot-1 of CAT 2023. So try to answer the question on your own. If you're not able to get it, then look at the video solution. If you have any doubts with respect to any of these LRDI questions, please do comment below the video. I look at all the comments and I'll try to answer them to the best of my ability.
Hi friends, welcome to Cracku's video series. In front of us is a fairly difficult LR set on scheduling. In an actual exam scenario, this would be a very challenging set to solve because this is not an easy set to first read through, understand and then solve as such. But once you actually get through, started with solving, it becomes very trivially easy as such. So let's take a look at the set. A visa processing office, VPO, accepts visa applications in 4 categories: US, UK, Schengen and others. The applications are scheduled for processing in 15-minute slots starting at 9 AM and ending at 2 PM. 10 applications are scheduled in each slot. There are 10 counters in the office, 4 dedicated to US applications, 2 each for UK applications, Schengen applications and others applications. So you have essentially 4 for US, 2 for UK, 2 for Schengen, 2 for others. This would be the distribution: 4 US, 2 UK, 2 Schengen and 2 others. And you have essentially 15-minute slot starting at 9 o'clock. So this is 9, this is 9:15, this is 9:30 and so on. Okay, so this is the idea. Now you're told that there are 10 counters. These applicants are called in for processing sequentially on first come first serve basis whenever a counter gets freed for their category. The processing time for an application is the same within each category, but it may vary across the categories. For each US and UK application, it requires 10 minutes. So this is 10 minutes, this is 10 minutes. And processing time. Depending on the number of applications in a category and the time required to process an application for that category, it is possible that an applicant for a slot may be processed later. So anybody who is scheduled for the first slot may actually get processed in the second slot or something like that. On a particular day, Xavier and Nandini were scheduled for Schengen visa processing in that order. They had a 9:15 AM slot, but they entered the VPO at 9:20 AM. When they entered the office, exactly 6 out of the 10 counters were either processing applications or had finished processing one and were ready to start the processing the next application. Mahira and Osman were scheduled in the 9:30 AM slot on that day for visa processing in the others category. The following additional information is known about that day. All slots were full. The number of US applications was the same in all the slots. The same was true for all the other all 3 categories. 50% of the applications were US applications. So you have essentially 10 applications for each slot. There are 20 slots. So total is 10 into 20. There are a total of 200 applications, of which 50% are US. So there is 100 US applications and there are the same number of applications per slot, 20 slots. So there are 5 US applications per slot. Now there'll be some for UK, there'll be some for Schengen and then there'll be some for others. We know that for Schengen visa, Ira, Vijay and Nandini were scheduled for the same slot, which means that at least 3 people are scheduled for the same slot for Schengen. So the number of applicants per slot for Schengen is greater than or equal to 3 per slot as such, because 3 Ira, Vijay and Nandini were at least scheduled the same slot. There might have been a 4th person or a 5th person in their slot, but at least 3 were scheduled for the same slot. So there is at least 3 per slot for Schengen. Similarly, Mahira and Osman were scheduled at 9:30 AM slot. So at least 2 were scheduled for the same slot for others. So this is at least 2 per slot as such. See, 5 per slot is over here. At least 3 plus slot is over here and at least 2 per slot is over here. But the overall number of applications per slot is how much? It is 10 per slot. And 5 plus 3 plus 2 is actually equal to 10, which means that there are 0 UK applications. There are 0 UK applications. There are exactly 3 Schengen applications and exactly 2 others applications, because 2 were called at the same time, Mahira and Osman. So those 2 are the only 2 who were called for that particular slot. 3 were called for Schengen, so exactly 3 are called for each Schengen slot. And since these add up to 10 applications per slot, which means that there are no UK applications at all. So how many UK applications were there? There were 0 UK applications. So essentially in each slot, I have to put in 5 US applications, I have to put 0 UK applications, I have to put 3 Schengen applications and I have to put 2 others applications. This is per slot as such. The US applications take 10 minutes per slot. So this will be, since there are 4 US, that would mean the first guy will work for 10 minutes, other guy will work for 10 minutes, the third guy will work for 10 minutes, the fourth guy will work for 10 minutes, and this fifth guy will have to wait for the first counter to finish, and then after the first counter is finished, he is going to start the fifth guys. So how will that be? I'll actually draw it out. But that is the basic idea as such. This is how the guys are distributed. Now it is given that Ira, Vijay and Nandini were scheduled for Schengen visa and they arrived late. Instead of coming at 9:15, they came at 9:20. Okay, we do not know how much time the Schengen visa is taking. We do not know how much time the others visa is taking. But there are clues given for that. So firstly, all slots are full. That is fine because 10 per slot were there. So all 10, there were 10 applications per slot. So this is done. Number of users applications were same. This is also understood. We have been able to infer how many applications are there per slot. This is also used up. Now essentially all applicants except Ira, Vijay and Nandini arrived at time. This is also something we can consider. Vijay was called to the counter at 9:25. So that basically means that the Schengen visa is being scheduled in such a way that Vijay, who came second, so on a particular day, Ira, Vijay and Nandini were scheduled to visa processing in that order. Before them, there'd be 3 people over here. These are the 3 people. So Vijay is essentially 5th in line and he was called at 9:25 AM, which basically means that when Ira entered at 9:20, she was probably called at 9:20 as such, and Vijay was called at 9:25 AM. There are 2 sections over here, right? So they basically, Vijay was 5th in line. Whatever is the time being taken, so the first 3 were there, okay? So let us actually take a longer look at the Schengen process. This is the first counter, this is the second counter. So let's say this is 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25 minutes. Vijay was called at the 25 minutes mark. So this is 5, 10, 15 and 20 and this is 25. Vijay was called at the 25 minutes mark. That would mean that, see the first slot, it would finish 1, say suppose it finishes 1, at some point of time it finishes 1, second also finishes 1 after X minutes, say this also after X minutes. Then it will call the third guy because in each slot there are 3 applicants. So the first counter is going to call the third guy. This is going to get finished and then you will call the fourth applicant will start. It was supposed to start at 9:15 and that would be Ira, and Ira's would also take another X minutes and would be done at some point of time. But because since Ira came late, her application would actually start, even though this is free after X minutes, her application would actually start at 9:20. So Ira's application would start at 9:20 and finish after X minutes. And Vijay would actually come over here in counter 2. Counter 1 would essentially process Vijay because every odd number is being processed by say counter 1, even number is being processed by counter 2. Since Vijay is 5th in line, he has to come to counter 1, which means that when he's called at this 25-minute mark, the process has exactly finished 2 applications, which means that this X minutes plus X minutes is 25 minutes, 2 X minutes is 25 minutes, which means that the Schengen visa is taking 12.5 minutes per application. I'll draw it out more carefully so that you are able to figure out what is going on. So what is happening over here is that the first counter, you have 3 applications, at 0-minute mark, 3 applicants come. So the first applicant is called to counter number 1. His application is finished processing in 12.5 minutes. The second applicant is called to the counter number 2. His application is also finished at 12.5 minutes. Now at 12.5 minutes, there was a third applicant in the first slot. Schengen visa has 3 applicants per slot, right? So that third application is started and that will finish at 9:25. This will be the other 12.5 minutes. All of these guys are from slot 1, okay? These are all from slot 1, the 3 applicants from slot 1. Now, after at 9:15, Ira's application was supposed to start processing because that was her slot. If she had come at 9:15, her application would have started over here. But because she came late, her actual application would actually start at 9:20 and then her application would take, so this is say 30 and 37.5. Her application would actually finish at 32.5 as such because this is 9:20 plus 12.5. Her application would finish at 9:32.5 minutes as such. So this is 12.5 minutes. This is slot number 2. This is Ira. This is Vijay who would come in over here and his application would finish at 9:37.5. 9:37.5, that is after another 12.5 minutes, his application would finish. Which means that from the fact that he's called at 9:25, I can infer that the Schengen application is taking 12.5 minutes per application. Now, we have only one which is left to figure out is basically others application time. If you have others application time, I can easily draw out this schedule for everybody. The way I have drawn this out for Schengen, I can even do that for the others also. UK, anyway, there are 0 applications. US, I know that there are 10 minutes per application, so I can easily show exactly how it is working. Now, the only one who is left is essentially others, and I don't know the time for that. So, even this is used up. So, do we have any idea or any kind of indication what would be the time required to process the others application? We are told that when Ira, Vijay and Nandini arrive at 9:20, exactly 6 of the 10 counters are either processing or had finished processing and were ready to start the next. Which means that 6 were working, 4 were resting, 4 were doing nothing, 4 counters were empty. Of these 4, 2 would be this one because UK has nothing to process, there are 0 applications. So that would mean that there were 2 counters which were not working. See, I know that there are US counters, there are like 5 applicants in 4 this, so there'll constantly be somebody who it is going to keep working on. Similarly, over here also, when these guys come at 9:20, both counters are either working or ready to work, which means that these two Schengen counters are also part of the 6 which are working. 4 of the US counters will definitely be working. I can draw that out because over here you have 10 per minute and you have like 4, 1, 2, 3, 4 counters. So each one of them, so suppose this is 10, 20, 30, 40, 50, 60, 70, 80, 90. So this is first 10. Each one of them process this is from the first slot, the 4 people who are there. And the 5th applicant will be finished on say the first counter at 9:20. At 9:15 you will get the next 5 applicants. So from 9:15 to 9:25 you will do the next processing. So there will be this is from the second slot. So over here also at 9:15 to 9:20 all 4 counters will be essentially working. Over here at 9:20 this will take the second guy. So over here also the first counter is also ready to work. So at 9:20 when it comes to the US applications, all 4 counters will definitely be working. All 2 counters of Schengen are working. So that basically means that the 2 UK counters are anyway empty because there are no applications. But it also means that the Schengen, the others visa counters were not working. They were empty. Basically, they had no applications to process, which means that they had buffer time. They had this free time that you see in the middle, right? They had that free time, which basically means that whenever they are processing, so if they are processing, say this is 9:15, 9:29, this and 9:10, 9:20, 9:30 and so on, that basically means at 9:10, there are these counters 1 and 2, there is slack time over here. At 9:20, the next, this has not come. So at every 15 minutes, they are getting something to do. So at 9 o'clock, they got 2 applications. So they will finish those 2 applications. At 9:15, they got 2 applications. They will finish those 2 applications. At 9:30, they'll get 2 applications. They'll finish those 2 applications. That means at 9:20, they had already finished the 9:15 a.m. applications, which means from 9:15 a.m. to 9:20 a.m., they had finished the applications. So essentially by 9:20 a.m., both others counters are free. Till 9:30 they are doing nothing because they have essentially processed the others applications between 9:15 and 9:20. At 9:20 they are free, they don't have any applicant in front of them, which means that the processing time for others is less than 5 minutes, less than or equal to 5 minutes, which means that they get at 9:15, by 9:20 definitely they are done with it and they are free, which means that at 9:20 they have nothing to do in front of them. So that means that the others application time is essentially it is anywhere between 1 to 5 minutes, so even half a minute. So essentially I know that the application time is less than or equal to 5 minutes. This is something that I can infer. So for the US I know it is 10 minutes. For the UK I know it is, there are no UK applications. For Schengen I know it is 12.5 minutes. And for others, I know that at max it is going to take 5 minutes. It is definitely done by 9:20. So that means that it is at most taking 5 minutes to do the others application. So this is something that I've been able to figure out. Now, after I figure out this US application, the 100 US applications, 5 per slot, each takes 10 minutes per slot. The UK applications are 0, so I can ignore. The Schengen applications are 3 per slot, each takes 12.5 minutes per slot, per application. There are 2 others applications per slot and it takes at max 5 minutes per application. This I have been able to figure out. Now I can draw my figures like this to figure out exactly when each application is being processed. So let us do that. Let us try to figure out when is each application essentially progressed. Let us see what is needed and based on that we'll figure out when each application is progressed. So let us go to the first question. So how many UK applications were scheduled that day? So we know there were 5 US, 2 others and 3 Schengen, but 0 UK. Per slot there are 0 and overall also there are 0. So how many UK applications were scheduled that day? 0 UK applications were scheduled that day. What is the maximum possible value of the total time in minutes nearest to its integer value required to process all applications in the others category on that day? So maximum possible time. So we have to figure out how much time will it take for the others category. See, I can say for the others that each of them is going to take at the most at max 5 minutes. So at 9 o'clock when you have, this is the counter, you get 2 of them. So this is say 5, 10, 15, 20, 30, 40 and so on. So at 9 o'clock you get 2 applications. By 9:05 at max it is done. These 2 first applications are done. This is from the first slot. So till 9:05, 9:10 till 9:15 they are doing nothing. At 9:15 they get 2 more applications. By 9:20 they are done. So this is from the second slot. This is also from the second slot. So this is done by 9:20. They are free again. So 9:15, 9:25, 9:30 they are doing nothing. At again 9:30 they get Mahira and Osman's applications. They finish that by 9:35. So this is the third application. This is done by 9:35. This is also done by 9:35. So again at 9:35 they are again free. So essentially at most they are taking 5 minutes per application. There are 2 applications per slot. There are 20 slots. So there are a total of 40 applications and 40 applications that each application at max is taking 5 minutes. So this is into 5. So at max this is taking 200 minutes as such. So what is the maximum possible total time in minutes nearest required to process all applications and other category that day? So the maximum possible value of total time, the processing time but not the start and end time, because each of these applications is actually coming after every 15 minutes. But the possible value of total time required to process, the processing time is essentially 200 minutes. So the answer to this is 200. The third question is, which of the following is closest to the time when Nandini's application process got over? So consider Nandini is basically 6th in line. This is the Schengen process. So this is say, let us consider there's this 12.5 minutes, so slightly odd. So we'll say that, let's say this is 5, 10, 15, 20, 25, 30, 35, 40 and so on. So this is 9 AM and each of these ticks is 5 minutes, okay, and there are counters 1 and 2. So for the first 3 applicants it is going to take 12.5 minutes each. So this is 1, 2 and 12.5 would be over here, somewhere in the middle over here. So this is over at 9.12.5. This is the first slot, first guy. This is the first slot, second guy. This is also done at 9.12.5. This is first slot. This is also first slot. This is also first slot. Then the first slot, third guy or the third applicant from the first slot will be processed and that will be done by 9:25. So this is 9:20. By 9:25, the third applicant of first slot is also done. So these 1, 2, 3 are done by the third slot. At 9:20, you start with ERA's application. ERA's application is going to take 12.5 minutes and it is going to be done by, this is 9, 5, 10, 15, 20, 25, 30. So this is 15. So you're going to start at not 9:15, you're starting at 9:20. So this is from here you will start ERA's application and it will finish at 9:32.5. So this will be the point at which you finish. So starting at 9:20, 9:32.5 is when ERA's application will be done. This is slot 2 and this is ERA. Okay. Now you start Vijay's application. Vijay's application starts at 9:25. It will get over at 9:37.5. So this would be over here somewhere, 9:37.5. So this is slot 2. This is Vijay. This is 9:37.5. Next is Nandini. This is getting over at 932.5. This slot counter is free at 932.5. This counter is free at 937.5. So Nandini process will be done over here. So Nandini's process will take another 12.5 minutes, which means that it will be done by 9:45 am. So this is slot 2. This is Nandini, and hers will get over 12.5 minutes after 9:32.5, which is 9:45 am. So when is Nandini's application process over? Nandini's application process is over at 9:45 am. In this, basically, I am drawing blocks. Each block is of length 12.5 minutes. The starting time is indicated by when the point is starting, and the ending time is basically when the process is ending. So Nandini, who is the third person in this particular schedule, her work will be done. This is the third block which refers to Nandini. Her work is done at 9:45 am. So the answer is option D. Let's consider the fourth question. Which of the following statements is false? The application process for Osman was completed before 9:45 am. So consider when application process for Osman is going to happen. So actually I did that over here only, right? Over here, if you see, this is the process for Osman and each one of them. Where is that? Both of them, each one of these is like 5 minutes, right? So actually I'll draw it out over here. For others, each one of them, each process is at max 5 minutes. So this is counter 1, this is counter 2, each tick is say 5 minutes. It need not even be 5 minutes, it is at max 5 minutes. So even the application processing time can be even 1 minute as such. So over here at 9 o'clock, you get 2 applications, you are done by 9:05. Okay, at max by 9:05 you are done. Then again at 9:15 you get 2 applications. By how much? 9:10 you are done. These are the 2 applications from slot 1. These are the 2 applications from slot 2. They are done. This is done by 9:05. These 2 applications are done by 9:20. Then again you do nothing till 9:30. At 9:30 you get Osman and Mahira's applications. You are definitely done at by 9:35 am. You are done with both Mahira as well as Osman. So Osman's application is done latest by 9:35 am. So Osman's application is definitely completed before 9:45 am. His application is latest complete by 9:35 am. So this is true. So I can eliminate this. The application process of Mahira started after Nandini's. This is not true because application process was Mahira started at 9:30 am, and I know from this that application from Nandini started at 9:32.5 am. So for Mahira it started at 9:30 am, for Nandini it started at 9:32.5 am. So who started before? So it started, Mahira's application process started before Nandini's. So this statement is not true. So B has to be the right answer. The application process of Osman was completed before Vijay's. See, Osman's application process is completed max by 9:35 am. Vijay's is completed by 9:37.5 am. So this is also true. Vijay's is completed by 9:37.5. Osman's is max completed by 9:35. So Osman's is completed before Vijay's. So this is also true. The application process of Mahira was completed before Nandini. This is definitely true. Nandini's is done by 9:45 am and Mahira's is latest done by 9:35 am. So this is also true. So D also can be eliminated. B is the right answer. The last question is, when did the application processing for all US applicants get over that day? Now, US applicants have not drawn it out, but let me draw it out. So, what happens over here? You have basically 5 applicants and 4 counters. So, the counters are 1, 2, 3 and 4. Okay. Each counter is going to take 10 minutes to do one application. So let us see, this is, each tick is say 5 minutes. Okay. So this is 20, 25, 30, 35, 40, 45, 50, 55 and 60. Let's see what happens in 1 hour. What happens? How many of these are completed in 1 hour? So here in this, you get 5 applicants. So over here, these guys are working for 10 minutes. This is applicant 1. This is the applicants. All of these 4 applicants are from slot 1. Okay. The 5th applicant from slot 1 has to wait. He has to wait for 10 minutes till one counter gets over. So the first counter, suppose, now starts working on the 5th applicant. So this 5th applicant is going to get over by 9:20 am. Till 9:15. Okay. The remaining counters are essentially having slack time. Why do they have slack time? Because there are 5 applicants per slot. 5 applicants per 15 minutes. So this 1, 2, 3, 4, 5 are done. So only the first counter is really busy after 9:10. After that, after 9:10 a.m., second, third and fourth counter are essentially chilling. So second, third, fourth counter are waiting. At 9:15 a.m., you get 5 more applicants. Again, that process starts. So this will be done at 9:15 a.m. to 9:25 a.m. Your second application will be over. Second slot applicant will be over again at 9:25. This second slot applicant will be done over at 9:25 again. Now there are 2 more second slot applicants left. The next one free time is over here, which is over here, and this second slot applicants will be done by 9:30 a.m. Okay. Now this is 1, 2, 3, 4. 4 people from second slot are done. We need 1 more person from the second slot. I'll put him over here. So this is the second slot. His work will be done by 9:35 a.m. as such. Okay. So this is from the second slot. Now again at 9:30 you get 5 more people coming in. Okay. 5 more applicants are ready for processing. So third and fourth slot are essentially chilling. After 9:25 their work is done. So they are essentially relaxing. Now you start again. You have at 9:30 you have 5 more applicants. So the first applicant will be spending time over here. This is the third slot, 10 minutes. This is again the third slot, 10 minutes. This is third slot, 10 minutes. 3 applicants have already been done by 9:40. Where will be the 1, 2, 3 are done, 2 applicants are remaining. The fourth applicant I'll put over here. His work will be done by 9:45 a.m. as such. So this is the third slot applicant. Where will the fifth applicant from third slot be put? I'll put him over here. Okay. So his work will be done by, this is 9:30, 9:40. His work will be done by 9:50 a.m. This is the third slot. So 1, 2, 3, 4, 5. 5 people from slot 1. 1, 2, 3, 4, 5. 5 people from slot 2. 1, 2, 3, 4, 5. 5 people from slot 3. So slot 3 essentially you are seeing the slot 3 work is done at 9:50 a.m. Now again you have another 5 people come in at, so 5 people came in at 9:15, 5 people came at 9, 9:15, 9:30, again 5 people came in at 9:45 a.m. So again over here, I'll put one guy over here, one applicant over here. So this is 4, this is again 4, this is again 4, 3 are done. Where will I put the fourth applicant? I have a empty counter at 9:50 a.m. So he will take that counter. So this will again be 4. So that basically means this is at, this is 10 a.m. as such. So 1, 2, 3, 4 are done. I need one more place, one more applicant is left from the fourth slot. So I'll put him over here, here, any one of these I can put. So again, he'll be done by what? This is the fifth applicant from slot 4. So this guy will be done. This is 9:55 a.m. So this will be done by 10:05 a.m. So you can see a trend emerging, okay. The first trend is that, see, the first slot, this is done at 9:20. So it is essentially extending by 5 minutes. Over here also the second slot, last guy is done at 9:30 a.m. So even this is extending, is 9:35 a.m. So even it is extending by 5 minutes. Over here also for the third slot, last applicant is done by how much? It is done by 9:50 a.m. So again extending by 5 minutes. Every slot is running late essentially by 5 minutes. The last applicant for each slot, instead of finishing before the start of the next slot, it is taking 5 more minutes to finish. Over here also it is extending by 5 minutes. Again after the fifth slot guys come, I can do the same thing. The fifth slot I will put over here, the first applicant over here, the second applicant over here, the third applicant over here. Then again I will put in the other 2 parts so that I can get the 5 applicants done. I'll put one over here, and again in one of the remaining parts I'll put one more applicant, such that eventually again I'll be overrunning at least this by 5 minutes. Essentially because there are 4 counters and 5 people, each time one counter has to do 20 minutes of work in 15-minute slot. So every time one counter is running or overrunning by 5 minutes. And because I have 4 counters, I can keep mixing which counter is overrunning by 5 minutes. In the first case, this counter overrun by 5 minutes, then the second counter overran by 5 minutes, in the third counter overran by 5 minutes, over here the second counter overran by 5 minutes. So I'm essentially switching which counter is overrunning by 5 minutes, but every single time one counter is overrunning by 5 minutes, which means that when will the last application be processed? See, essentially every slot, it is from 9 to 9:15. 9:15 to 9:30. The last ending slot is 2 o'clock. But I am overrunning by 5 minutes. So when will my applications finally be over? It will be over at 2:05 p.m. That was when you're overrunning for the last time by 5 minutes, and your last application will be finished. The last applicant of your last slot will be done by 2:05 p.m. So the all the applicants work will be done by 2:05 p.m., which is option A.
In this question, we are told that there is block X and block Y. There are 6 houses in block X across 3 columns, 2 houses in each column. There are 6 houses in block YY. Again, there are 3 columns and 2 houses in each column. Now, what we are told is that some of these houses are occupied, some of these houses are empty. The empty houses are actually on the market to be sold. And the price for every house, if it has a parking space, is 12 lakhs. If it has no parking space, it is 10 lakhs. So it can be either 10 or 12 based on the house itself. Based on the road access, we have something called the road access premium. It is road adjacency value. This is RAV. Now a house can have 0 roads in its access. Houses like B1, A1, they don't have any road. Similarly, F1 and E1 have no road, or they can have 1 road access, like C1 has 1 road access, A2 and B2 have 1 road access, F2 has 1 road access, E2 has 1 road access, and D1 has 1 road access. Or it can have 2 roads access. C2 has 2 roads access and D2 has 2 roads access. Now you multiply this with 5, because the formula to calculate the price is 5 times the road adjacency value. So if it has no road access, it will be 0. If it has 1 road access, it is 5. If it has 2 road access, it is 10. This is the additional premium that you pay for the road adjacency value. Similarly, based on the neighbors, there is something called the neighbor count. The neighbor count is either 0. If there is a house which is surrounded by all vacant houses, the neighbor count is 0. Or it can have 1, or it can have 2, or it can have 3. The maximum number of neighbors that a house can have is 3. For example, B1 over here, if there are owners, if there are occupants in A1, B2 and C1, it will have 3 neighbors. If B1 has only 1 neighbor, then its neighbor count will be 1. If only 2 out of these 3 houses are occupied, it will have 2. If all 3 are occupied, it will have 3. So the maximum number of neighbors a house can have is 3. And you multiply the neighbor count with 3 to add it to the premium. So the price, because of the neighbor count, will be either 0 or 3 or 6 or 9. What we are told is that in XX, the maximum quoted price of a house in XX is 24. So if you are looking at XX, these are the 3 houses in XX. The maximum price quoted over here is 24. So all of them are less than or equal to 24. Similarly, in YY, the minimum price quoted is 15. So if this is YY, this will say is XX, and this is YY. All the houses quoted are greater than or equal to 15. We are also told that one such house exists in column E. So one of these 2 houses is equal to 15 lakhs. Row 1 has 2 occupied houses, 1 in each block. So 1 out of these 3 is occupied. Remaining 2 are unoccupied. Similarly, 1 out of these 3 is occupied and 2 are unoccupied. We'll put occupied as O to avoid confusion, and vacant will put as X. Both the columns in column E are vacant. So this is vacant, this is vacant. Okay. Each column of column D has at least 1 occupied house. So one of these 2 is occupied, at least one of these 2 is occupied, and at least one of these 2 is occupied. There is only 1 house with parking space in block Y. So in block Y, there is only 1 house with parking space. This is the information that is given. Based on it, we have to figure out which of the houses are occupied and which of the houses are not occupied. If you are looking at XX, the only real information that we have is that there is 1 house which is priced at 24 crores. Every other house is priced less than that. So how can we get this 24 lakhs? 24 lakhs, if the base value is 12, if the base value is 10, this will be 10 plus, if this is 5, 10 plus 5 plus 9. This is one way of getting 24. 10 plus 0, if this is 0 over here, we need 14, that is not happening. If 10 plus 5, we are getting 9. If it is 10 plus 10 over here, we need 4 from the neighbor count. That is not there. So if it is 10 over here, the only possibility is 10 plus 5 plus 9. If the base value is 12, and if the road axis value is 0, you need 12 more that we are not getting from the neighbor count. 12 plus 5 would be 17. You need 7 from the neighbor count. That also is not happening. 12 plus 10 is 22. You need 2 from the neighbor count. That also is not happening. So the only possible value is 10 plus 5 plus 9. But how exactly are you getting 10 plus 5 plus 9? This has to be 10, which is no parking, plus 5, which would mean that it has one road access, plus 9, which would imply that it has 3 neighbors, the 3 neighbor count. Which of these houses has one road access? If you are looking at the road access from XX, this has 0 road access, this has 0 road access, this has 1 road access, this has 1 road access, this has 1 road access, this has 2 road access. We need a house which has exactly 1 road access. So it is not this one, it is not this one, it is not this one. The remaining 3, that is A2, B2 and C1, have exactly 1 road access. But we also need 3 neighbor counts. A2 has at most 2 neighbor counts. They will be this guy A1 and B2. A2 has only 2 neighbors. If both of them are occupied, it will have 2 neighbor count. So it is not A2. Similarly, C1 also has a maximum of 2 neighbors. They are B1 and C2 if both of them are occupied. So it is not even C1. So the only possibility this will work out is if it is B2. So let us write XX over here. This is XX. This is A1. This is B1. This is C1. This is A2. This is B2 and this is C2. We are saying that this has to be empty and this will be worth 24 lakhs. This is occupied, this is occupied, this is occupied because we need 3 neighbors for this guy. Now what about A1 and B1? What we are told over here is that row 1 has 2 occupied houses, 1 in each block. We know that B2 is occupied. So this has to be empty and this has to be empty. So we have filled which house is empty, which house is not empty in XX. Let us do the same for even YY. What is the information we know about YY? We know some information about YY. We know that all of these houses are worth at least 15 lakhs. And we also know that one of the house which is worth 15 lakhs is in row E. This is mentioned to us. Both the houses are vacant, so we'll put an X over here and we'll put an X over here. Let us try to figure out which of these 2 houses is actually worth 15 lakhs. If you're looking for a split of 15, again going back over here, this is either 10 plus 5 plus 0, or it is this 15 is equal to 12 plus 0 plus 3. Because we need to pick one of 10 or 12 from here. We need to pick one of 0, 5, 10 from here. We need to pick one of 0, 3, 6 and 9 from here. There are only 2 possibilities. Either 15 is 10 plus 5 plus 0 or 15 is 12 plus 0 plus 3. Now based on it, if you are looking at YY, if you are looking at it as 12 plus 0 plus 3, what does this imply? This implies that, or if you are looking at 10 plus 5 plus 0, what does this imply? This implies that this has no parking, this flat. This has one road access. And this has no neighbors. If this is the split of 15, it would imply that empty flat should have road access. So that means it has to be E2. So if you are drawing YY over here, this is D1, E1, C1. This is D2, E2 and C2. If the 15 is 10 plus 5 plus 0, E2 has to be the one which is empty. And this is worth 15 lakhs. Because we need road access over here. This would imply that it has no neighbors. So this is empty, and this is empty. We are also told that at least one house in D and one house in F is occupied. So both of them have to be occupied. Now how many houses are occupied in row 1? We already know that B2 is occupied and we are getting 2 houses which are occupied in YY, block YY. That is a contradiction. Why is that a contradiction? Because we are told that row 1 has 2 occupied houses, 1 in each block. In block XX, we already know that it is B1 which is occupied. In block YY, in this case, we are getting 2 houses as occupied. We are getting 2 houses as occupied because we know that column D and F have at least one occupied house, and D2 and F2 are vacant. So this case can't exist. This would imply that 15 has to come from 12 plus 0 plus 3. That is, it has no road access. This would imply that this has to be 15 over here. This is 12 plus 0 plus 3. This would imply that this is the house with the parking. No other house has parking. And this has exactly one neighbor because we have 3 over here. This is 3 into 1. But is it D1 or is it F1? That is not sure. That anything is possible. We'll draw all the cases. If D1 is vacant, let me clear this. This is X and this is X. This is 15. If D1 is vacant, this would imply that F1 is occupied. If F1 is vacant, this would imply that D1 is occupied. What about D2 and F2? In the first case, we know for sure because we need at least one house in column D and column F to be occupied. Because in the first case, D1 is vacant, D2 has to be occupied. In the second case, because F1 is vacant, F2 has to be occupied. In the first case, what about F2? This one. This can be either occupied or vacant. Similarly, in the second case, D2 is either occupied or vacant because we are not told that exactly one house in column D and D is occupied. We are told that at least one house is occupied. So there are multiple cases possible, but this is the best that we can do. Let us go ahead and answer the questions that follow. How many houses are vacant in block X? In block X, we know for sure that 3 houses are vacant. They are A1, B2 and C1. Which of the following houses is definitely occupied? A1 is definitely vacant. D2 is either occupied or vacant. B1 is definitely occupied. B1 is over here, it is always occupied. So the correct answer is B1. F2 also is either occupied or vacant. Which of the following best describes the number of vacant houses in row 2? In row 2 in XX, we have one vacant house. That is B2. In block YY, we have definitely one vacant house, which is E2. And either F2 or D2 can be vacant. So the correct answer is 2 or 3. The 2 houses which are definitely vacant are B2 and E2, and either 0 or 1 houses are vacant between D2 and F2. So it is either 2 or 3. What is the maximum possible quoted price in lakhs of a vacant house in E? In E, we are basically looking for this one. It is 10 because it has no parking. Because E1 has parking, E2 will not have parking, so it is definitely 10. It has road access, so we will add 5 to it. It has 1 road access. What about the number of occupied houses? The occupied houses is either 1 or 2, the number of occupied houses which are neighbors of E2. But because we are trying to maximize it, it will be 6, which is 2 occupied houses into 3. This is equal to 21 lakhs. Which block in block YY has parking space? Parking space is there in E1.
Google search Cracku free CAT mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 CAT aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
Hi friends, welcome to Cracku's video series. I'm Saili Kale. In front of us is a DILR set that came in CAT 2023. This is not a difficult set, but a lot of students found it difficult because it used the concepts of mean median mode. Concepts of mean median mode are not difficult concepts at all. They are very easy to revise as such. And if you know the concepts, this becomes essentially a simple enumeration puzzle, a simple arrangement plus enumeration puzzle. So let us first revise the concepts of mean median mode. Once you understand what are the concepts of mean median mode, this will become super simple to solve. So what is mean? Mean is basically your average. If you have the values 1, 2, 3, 4, 5, the mean is the sum of all of these values. So this will be 1 plus 2 plus 3 plus 4 plus 5 divided by the number of terms, which in this case is 5. So this is equal to how much? This is equal to 3, 6, 10, 15. So the mean is 3. So this is the sum of the terms divided by the total number of terms. What is median? Median is that if you arrange the terms in increasing order. So for example, if you have 1, 2, 4, 3, 2, first thing that you have to essentially do is arrange all of these terms in increasing order. So if I arrange them in increasing order, I'll get this. And the middle term after arranging in increasing order is the median. So if I arrange all of these in increasing order, the middle term is 2. So 2 is the median. If suppose I have an even number of terms, then there will be 2 middle terms. Then what do you do? So suppose I have the terms that are there are 1, 5, 3, 4, 6, 2. Alright, this is too simple. 1, 5, 4, 4, 6. Okay, if I arrange this, there are 6 terms as such. So because there are 6 terms, if I first arrange them in increasing order, this will be 1, 3, 4, 4, 5, 6. Now there are 2 middle terms. These two are both are middle terms. So what should be the median? The median in such cases, when you have even number of terms, is the average or the mean of the middle two values. So in this case, it will be 4 plus 4 by 2. So that will be equal to 4. Suppose the middle two terms are say 3 and 7. This will be 3 plus 7 by 2. So the median would be 5. So it is entirely possible that the median is not even part of the set. So the median can be, in case there are even number of terms, the median can even be not part of the set as such. The mean also can be not part of the set. The median also can be not part of the set. If there are odd number of terms, the median is definitely part of the set. If there are even number of terms, it is the average of the middle two terms. And it is possible that median is in that case, it is a decimal value, because you can get, the sum can be odd and then you will get 0.5. Or it can be not even a part of the set. It's basically the average of the middle two terms. So this is mean and median. What about mode? I'm sure many of you would have heard about mean and median but not heard about mode. Mode is basically, if you take any set of values, mode is the value which is the most number of times, the number that comes most number of times in that set. So suppose you have 1, 5, 3, 2, 5, 7, 2. So in this case, what is the mode of this set? So first I arrange in increasing order. 1, 2, 2. Then you have 3. Then you have 5 and 5 and 7. So in this case, you have 2 which comes twice and you have 5 which comes twice, and the remaining terms come only once. So which two numbers are appearing multiple times or more than one time? That is 2 and 5. So the mode in this case, here you have 2 modes for this set. The mode is 2 as well as 5. So basically this is a set of numbers which come the max number of times in this particular set. Suppose if I add 5 to this set, now the set is 1, 2, 2, 3, 5, 5, 5 and 7. So 5 will come thrice. So it is the single mode in that case, because it would be the highest frequency, the number with the highest frequency, and the number with the highest frequency, if there is a single number, then it is the singular mode of that particular set. So if there is one more 5, 5 will have the frequency of 3, which would mean it is the single mode of the particular set. So mode is nothing other than the number which appears the most number of times. In this case, if there are multiple numbers that appear equal number of times, then there will be multiple modes as such. Okay, so this is the basic idea. Now let's take a look at the set. 5 restaurants coded R1, R2, R3, R4 and R5 give integer ratings to 5 gig workers, Ullas, Vasu, Vaman, Xavier, so UVW, XY on a scale of 1 to 5. The means of ratings given by R1, R2, R3, R4 and R5 were 3.4, 2.2, 3.8, 2.8 and 3.4 respectively. The summary statistics of these ratings for the 5 workers is given below. So these are integer ratings and the average of these ratings, that is the mean of these ratings, is given. Okay. Now we are told the mean of these ratings is given, then the mean of the ratings given by restaurant wise is given and the individual wise is also given. Median rating individual wise is given, modal rating individual wise is given, range of rating is given. What is range? Range I didn't discuss. So basically in a given set, suppose this is the set, okay, 1, 4, 3, 7, 2 as such. The range of the set is the highest minus the lowest. The highest item is 7, so 7 minus the lowest, which is 1. So 7 minus 1, the range of the set is 6. This is the basic idea as such. These are all set theory concepts and they are not difficult concepts as such. So this information is given. Range of ratings, so they have given, defined as the difference between the maximum and minimum ratings awarded to a worker. The following is a partial information about ratings of 1 and 5 awarded by the restaurant to the workers. So R1 awarded a rating of 5 to Vaman, as did R2 to Xavier, R3 to Vaman and Xavier, and R5 to Vasu. R1 awarded a rating of 1 to Ullas, as did R2 to Vaman and Yusuf, and R3 to Yusuf. So basically some information is given. If you look at the clues, they are giving you where the ratings have been. So this is like a table with missing values. Some information of restaurant and person is given, but some information has to be inferred as such. So this essentially means that I have information person wise as well as restaurant wise, and I have to find individual information as to which restaurant gave which particular person what rating. So there are 5 people, U, V, W, X and Y, and then there are 5 restaurants, R1, R2, R3, R4, R5. And then we have values for Ullas, Villas, this Basu, etc. We have values for median, modal and range of rating as such. So all of that we'll consider once. So let us consider what is the values that are given. Firstly, we are told that mean of ratings of R1, R2 are 3.4, 2.2, 3.8, 2.8, 3.4. All of these values inside the cell have to be integer because we have been told these are integer ratings. So that basically means there are 5 ratings. The average of 5 is 3.4. So 3.4 into 5 will give you the sum of ratings. So sum of ratings given by R1 is 17, that is 3.4 into 5. By R2 is 2.2 into 5, which is 11. By R3 is 3.8 into 5, which is 19. 2.8 into 5, which is 14. And 3.14 into 5, which is 17. So this information I am able to find out. Similarly, mean rating for Ullas is 2.2, so multiplied by 5 would be 11, 19, 17, 18 and 13. This would be the mean or the sum of ratings received by each one of them. Median rating for this person is 2. So this is the sum, this is the median and this is the mode, for example. The median rating is 2 and the modal rating is 2. Here the median rating is 4 and the modal rating is 4. The median rating is for Vaman is 4 and the modal rating is 5. For median rating is 4 and the modal rating is 5. The median rating is 4 and the modal rating, sorry, this is 4 and 5, this is 3 and 1 and 4. So there are 2 modes as such. Okay. So from this, can I try to infer what is the value or what was the score scored by each one of them? Another information is given. Partial information about ratings of 1 and 5 are given. R1 awarded the rating of 5 to Vaman. So this is 5. And as did R2 to Xavier, so this is 5, and R3 to Vaman and Xavier, so R3 to Vaman and Xavier, and R5 to Vasu, so this is 5. R1 awarded a rating of 1 to Ullas, and as did R2 to Vaman, so R2 to Vaman is 1, and you have Vaman and Yusuf, so this is 1 and 1. And R3 to Yusuf, so this is also 1. So this information has been given as such. Now the remaining missing values I have to essentially infer based on the median, modal rating and range of ratings. From that I should essentially figure out what should be Ullas's rating. So from the column sums and the row sums and the mean and median, I should be able to fill out this 5 into 5 table. That is the task at hand. So consider Ullas's rating. So Ullas's rating, the sum is 11. The median rating is 2, so that means if these are the 5 values, okay, the median is 2 as such, because there are 5 values, odd number of numbers, the middle rating would be the median rating. So this is 2 as such. The modal rating is 2, so 2 comes the most number of times, and range of rating is 3, which means that if this is 1, the max is 4, if this is 2, the max is 5 as such. Over here, consider the case for Ullas. Since 1 is given, this has to be 1. 1 is definitely there because 1 is the rating given by this as such. So the minimum is at least 1, which means that given the range of rating, this max has to be 4 as such. I am considering in the, if I arrange it in ascending orders, the min would be 1, the max would be 4 because the range of the ratings is 3. So I have been able to fill out 1, 2, 3 parts of this rating. I know that his sum is 11, so this plus this should be how much? This is sum is 7, so this plus this should be equal to 4 as such. The modal of the rating is 2. So 4 can be either 1 and 3 or it can be 2 and 2. Since mode is 2, see if it was 1 and 3, the mode would have been 1. If it was 1 and 3 over here, the mode of Ullas would have been 1 because 1 comes twice and 2 and 3, 4 come once. So mode would have been 1. But since mode is 2, which means that it is not 1 plus 3 but it is 2 plus 2 as such. So that basically means that the values for Ullas are 1, 2, 2, 2, 4. They will be in some order, it will not necessarily be in this order because in some order it should be 1, 2, 2, 2, 4. Only this 1 is put over here but 2, 2, 2 and 4 should be in some particular order. We'll take a look at that later. Now consider the same for V. So for V you have the value, so you have the sum is equal to how much? Sum for Vasu is 19. Sum for Vasu is 19, so consider the values over here. For Vasu, the median rating is 4, so this is 4. The range is 3. Is any particular value for Vasu known? See, the 5 is known, so he has scored at least 1 5. So the max is 5, that is definitely there, which means that if the range is 3, the mean has to be 2 as such. So that means this minimum, maximum and median has been fixed as such. So the only thing that is remaining are the remaining two values. What is the sum of this? This sum is 11. So the remaining sum of these two should be how much? This 2 should be equal to 8. Now this 8 can be 2 plus 6, no, 6, the rating is only 1 from 1 to 5. So this can be 3 plus 5 or it can be 4 plus 4. These are the only two possibilities. If it is 3 and 5, what would be the mode of this? If this is 3 and 5, mode will be 5. But in the case of Vasu, mode is 4, which means that it can't be 3 and 5, it has to be 4 and 4. So these values have to be 2, 4, 4, 4 and 5. So this basically I can figure out what are Vasu's ratings also. In some order, they should be 2, 4, 4, 4 and 5. Okay. Now let's do the same for Vaman's rating. Vaman's total sum is 17. Okay. His median rating is 4. Okay. Over here he is getting 4. His scores, there is 1 and 5 in his scores. So 1 and 5 means the minimum is definitely 1, the maximum is definitely 5. And there are 2 5s for Vaman. So there are 2 5s that are definitely I know, and median is 4 as such. So I can fill this much. And the sum is 17, so I can fill the whole thing as such. This is 10, 14, 15. So this has to be 2. So the score, exact score for like the scores of Vaman in some order should be 1, 2, 4, 5, 5. So this should be 2 and 4 in some order. Okay. So let us take a look at the same for Xavier. For Xavier, the sum is 18 and the median is how much? The median is 4. So this median is 4. The range is also 4. And let's see if he has any this. So he has 2 5s as such. So these two are 5s. And since the range is 4, this has to be 1. So let us consider the sum again. So this would mean that this has to be 3 as such. Only then would the sum be equal to 18 as such. So I am able to figure out Xavier's score also, that it should be 1, 3, 4, 5, 5. So this should be 1, 3 and 4 in some order. Consider Yusuf's score. Yusuf's score is total is 2.6. So this total sum is 13. These are suppose the 5 values. The median rating is 3. The modal rating is 1 and 4, which means there are 2 1s and 2 4s as such. So from that alone I can say this is 1 1 and 4 4. Otherwise you would not have the mode as 1 and 4, because at max they can come twice because 3 is also there. And if 3 is repeated, then 3 will also be one of the modes as such. So since 3 is not one of the modes, each has to come twice. So the number of ratings should be 1 1, 3, 4, 4. So the median is 3, the modal ratings are 1 and 1, 4 and 4, and the range is 3 clearly because it is 4 minus 1. So everybody is this I can figure out right now. So let me actually put that. So whatever is missing I'll put over here. So whatever are the missing values I can put over here, and then from that I can try to figure out where they will fit. Okay, sorry. So I can say that for Ullas 2, 2, 2 and 4 have to be fit over here in some order. Then you have for Vasu, you have to fit 2, 4, 4 and 4 in some order. For Vaman, you have to fit 1, 2, 4, 4, 5. So 2 and 4 are there in some order over here. Then for Xavier, 1, 3, 4, 5, 5. So 1, 3 and 4 have to be fit in some order. For Yusuf, 1, 1, 3, 3, 4, 4. So 1, 1 is already there. So 3, 4, 4 have to be fit in some order. Now how do I figure out which cells do they actually go to? Now I have to use the column totals. Only with the column totals will I be able to figure it out. Now consider R3 column, okay. In R3 column, you have 5 plus 5 plus 1, which is what? The total is 11. This is 19, which means that the remaining total to be explained is 8. Now, the max value, these two should add up to 8. These are 2, 2, 4, 4, 2, 2, 4, 2, 4, 4, 4 as such. Now, if you have value of 2 over here, for example, this will have to be 6 only, then it will become 8, but it can't be 6 as such, which means that you can't put 2 over here. The least value you can put over here is 4, and this also has to be 4, and using this only can you add up to 19 as such. This is the only way it will add up to 19, which means that 4 is gone and the remaining values of 2 can be filled in the missing values of the table, and this 4 is also gone. So I can say that this has to be 4 and 4 and the remaining values can be filled like this. Now consider this R2 total. Here this is 11 and the remaining values are already filled out. So this is 2 plus 1 is 3 plus 5 is 8 plus 1 is 9. So this has to be 2. So the 2 is filled out. So the remaining values of 4 can be filled out as such. So this is also filled out. This is also filled out. So the first 2 rows are completely filled out. Now I am left with this column and this column as such. So 2 and 4 can be there in some particular order. Consider this total as such, which is 17. Now suppose you have 2 over here. Okay, so this will become 2 plus 5 plus 5, 2 plus 5 plus 2, that will be equal to 9, which would mean that this sum has to be equal to 8, which would mean that 4 and 4 have to be there. Only then you will get 17 as such. So let us consider that there is a possibility of that happening. Now consider over here, this is 1 plus 4 plus 5. So then you will have 7 that is needed, which would mean that in case that is the case, you will need 7. So 3 and 4 have to be there in some particular order. So you cannot put 1 over here because this would mean that if 1 is over here, you cannot reach 17 total. If 1 is over here, can you reach 17 total as such? Let's consider. So suppose if I put 1 over here, this is 2 plus 7, 8. 9 is needed. But the highest value for both of these is 4 and 4. So if this is 1 over here, this at max can be another 8, which would mean that the total at max can be 16. You cannot reach 17, which means that over here also I cannot put 1. So 1 cannot be in this column, 1 cannot be in this cell. So the only cell where 1 can be is this particular cell. So that would mean that this has to be, I can remove this and I can say that 1 cannot be in this column. 1 cannot be in this column because the sum of 17 cannot be achieved if I put 1 in either of these two sets. So 1 will have to be over here, which would mean that 3 and 4 have to be in some order over here. Let's keep that for now. This is equal to 14, okay. So let us consider what happens when this is equal to 14. This sum has to be, you have to put 3, 4, 4 in some particular order. This has to be 3 and 4 in some particular order. And you have 3 and 4 over in some particular order over here. And you have 2 and 4 in some order. Now you have put 1 over here, this is 14. So 2 plus 4 is 6 plus 1 is how much? 2 plus 4 is 6 plus 1 is 7. Now if I put 2 over here, what will happen? If I put 2 over here, that will become equal to 9. Okay, this is 8 plus 1, 9, which would mean that this will have to be equal to 5. But I do not have a 5 to fill as such, which means that I cannot put 2 over here. This has to be 4. Which means that this has to be 2. So this means that I can fill this column. How much is this? This is 8, 10, 11. So this has to be 3 over here. This 3 is gone. I can put 4 over here and 4 over here, which means that this has to be 3 and this has to be equal to 4. So that basically means by using the concept of row total, column total, mean, median, mode, I am able to fill out all the values. I know exactly for all restaurants, I know exactly what ratings they give, and for every person I know exactly what rating they received. So I have the final table. Now let's go and answer the questions. How many individual ratings cannot be determined from the above information? All ratings can be inferred. All 5 into 5, that is all 25 ratings can be inferred. So the answer is 0. How many workers did R2 give a rating of 4 to? So consider R2. R2 did not give anybody a rating of 4. This is R2's column. He did not give anybody a rating of 4. So this is 0 again. Consider question 3. What rating did R1 give to Xavier? R1 to Xavier is 3. So this answer is 3. What is the median of the ratings given by R3 to the 5 workers? R3 to the 5 workers, you have 1, 4, 4, 5, 5. So if I arrange in an increasing order, I get this is the ratings in an increasing order. The median is 4. So the median of R3's ratings is 4. Then the last question is, which among the following restaurants gave the median rating to exactly one among the workers? So median rating of this person is 1, 3, 4, 4, 5. So 4 is the median rating and 4 has come twice. So he has given it to more than one people. Here the median rating is 1, 1, 2, 2, 5. So median is 2 and it comes twice. So he has given it to more than one person. R3 it is 1, 4, 4, 5, 5. 4 is the median. It comes twice. So again does not satisfy. This is 1, 2, 3, 4, 4. 3 is the median, comes exactly once. So R4 has given its median rating only to one person. This is 2, 2, 4, 4, 5. 4 is the median, 4 comes twice. So that also does not satisfy the condition. So R4 has given its rating to exactly, median rating to exactly one of the workers. So answer is option C. So in this case, basically what did we have to do? We needed to know the basics of set theory, that is what is mean, median, mode and range of a set. And after that, we had to generally use the table with missing values concepts of row total, column total to fill out the values. So very simple set as such. Basically, you just need to know basics of set theory, and it is a simple table with missing values set as such. In table with missing values, if you write down what values are left, if you write down to the next, in over here you write down the column totals. Once the totals are in front of you, it becomes easier to solve. If you don't write them down, it is harder to solve the set. This should, the value of each column total should be in front of your eyes. If it is in front of your eyes, you will immediately see that, yeah, this is the case. If each value 3, 4, 1, 3, 4 is in front of your eyes, you know that, okay, it can't take the value 5, it can't take the value it can't take the value 2. Once all of that is very evident, it is easier to fill out the missing values as such. So this is basically how you solve questions of this type. Hi friends, welcome to Cracku's video series. I'm Saili Kale. In this particular video, we'll be taking a look at it's an arrangement kind of set from CAT 2023. So let's first take a look at the set and then let's decide how to actually represent the information given. Faculty members in a management school can belong to one of the 4 departments: finance and accounting, marketing and strategy (M&S), operations and quants (O&Q), and behavior and human resources (B&H). The numbers of faculties in F&A, M&S, O&Q and B&H departments are 9, 7, 5 and 3 respectively. Professor Pakrasi, Professor Qureshi, Professor Ramaswamy and Professor Samuel, so they are PQRS, I will be referring them to as PQRS throughout, are 4 members of the school's faculty who were candidates for the post of the Dean of the school. Only one of the candidates was from O&Q. Every faculty member, including the 4 candidates, voted for the post. In each department, all the faculty members who were not candidates voted for the same candidate. The rules for the elections are listed below. There cannot be more than 2 candidates from a single department. A candidate cannot vote for himself or herself. Faculty members cannot vote for a candidate from their own department. So this is the basic information that is given. After the election, it was observed that Professor Pakrasi had 3 votes, Professor Qureshi had 14 votes, Professor Ramaswamy had 6 votes, and Professor Samuel had 1 vote. Professor Pakrasi voted for Professor Ramaswamy, Professor Qureshi voted for Professor Samuel, Professor Ramaswamy voted for Professor Qureshi, and Professor Samuel for Professor Pakrasi. So essentially what information we have information of the candidates, and we have information of how many votes they have and who could have potentially voted for them. So how many votes are there in each department and how the candidates themselves voted among each other, that information is essentially given. So we have to essentially represent who got how many votes and how the votes got distributed. So let us see the best way to represent any information of this type, where there is like arrangement of votes or arrangement or distribution of votes as such, is a table format. In this table, how would you draw the table? So basically you are telling how many votes P has to get, how many votes Q has to get, how many votes R has to get, and how many votes S has to get. So I will make P, Q, R, S and the votes that they got as the rows. So there are these 4 candidates, so they will be the rows of my table. Now, where can they get their votes from? They can get the votes from the 4 departments, barring the candidates, and the 4 candidates themselves. So for the 4 departments, I will show that these are the 4 departments and this is how the departments have voted. So this is for the departments section, and then there is this candidate section where PQRS will vote among themselves for other candidates as such. That information is already known. So this is the total, and each person over here there is 1 vote, and for each department the number of total votes of the department are given. So let us see. Now it is told that P has received how many votes? He has received 3 votes. Qureshi has received 14 votes. Ramaswamy has received 6 votes, and Samuel has received 1 vote. Of this, we are told that Pakrasi voted for Ramaswamy. So this Pakrasi will vote for Ramaswamy. So this is 1 vote from here. So everything else can be eliminated. Then you have Qureshi voted for Samuel. So Qureshi voted for Samuel. So there is 1 vote over here. everything else is going to be crossed out. So this is essentially, I'm filling it the way I would fill an arrangement table. The moment you put a tick or any particular vote over here, you're not going to have them vote for anybody else. You have Ramaswamy voted for Qureshi, so you have one vote over here, and everything else is going to be crossed out. And Samuel voted for Pakrasi, so you have one vote over here, and everything else is crossed out as such. So this is the information that I can conclude. In the department, so I have F and A, M and S, O and Q, and behavior and human resources. Now, how many people does F and A have? That department has 9 people. M and S has 7 people. O and Q has 5 people, and B and H has 3 people as such. So this is this O and Q has 5 people, B and H has 3 people as such. And we don't know how many candidates are there from each of these, but we know that at max 2 candidates are there from any particular department. So that means that at the very least 7 people have voted from the finance and this department for one person, or at max 9 has voted. If 0 candidates is from F&A, then at max 9 would have voted from this. So from finance department, barring the candidates, there will be 7 to 9 votes. From M and S department, M and S department, if there are 0 candidates, then there will be 7 more votes, at max 7 votes. And if there are 2 candidates, because there can be a max of 2 candidates, there will be at least 5 votes as such. So 5 to 7 votes have been from this particular department. From O, I know that there is exactly 1 candidate, so there will be exactly 4 non-candidate votes, and there will be exactly 1 candidate from this particular department. From behavioral, this basically at least there can be, if there are 2 candidates, there will be exactly 1 vote. If there is 0 candidate, there can be at max 3 votes as such. So this is 1 to 3 as such. Now this is the information that I have. Now this row total has to add up to 3. How can it add up to 3? Can I have 4 votes and this 1 vote, can it add up to 3? No. Can I have 5 to 7 votes? Because all people from one particular department are going to vote for only one person. So there cannot be more than 2 candidates. This rule I have considered over here. A candidate cannot vote for himself or herself, so that has already been taken care of. We have been told who they have voted for. Faculty members cannot vote for a candidate from their own department. So if Pakrasi has voted for Samuel, they are not from the same department, or Samuel has voted for Pakrasi in this case, they are not from the same department. So this is something that I already know now. Now, basically, we are also told that every faculty member, including the 4 candidates, voted for the post. In each department, all the faculty members who were not candidates voted for the same candidate, meaning all these 7 to 9 votes will go to one guy, all these 5 to 7 votes will go to one guy, all these 4 votes will go to one guy, all these 1 to 3 votes will go to one guy. Now, if I look at the totals over here, there are 3 votes over here, there are 14 votes over here, there are 6 votes over here and 1 vote over here. Can these 7 to 9 votes go to the person who has scored a total of 3 votes? No, because then the row total, that row total will definitely be above 3 as such. So, F&A definitely didn't vote for Pakrasi. Similarly, can it go to somebody whose total is 6? So, the remaining votes are 5. So, if this is 7 to 9, they definitely didn't go over here. This row total is 1. So again, these guys definitely didn't vote for Samuel. So they will have definitely voted for Qureshi. So this is 7 to 9 will come from here as such. So this is definitely they have voted for Qureshi. Now consider M and A. Can they vote for somebody? So 1 vote is already over here. So from departments, you need 2 votes. There is 2 votes and this is 5 to 7. So this is definitely not the case. This is 6. So 5 to 7 could possibly work. This is 1. So this is also definitely not the case because this is 5 to 7 votes. Consider this is 4 votes. 4 votes basically means that you will directly get, if you put 4 over here, 4 plus 1, this will become 5. So this guy, O did not, O and Q department definitely didn't vote for Pakrasi. So this is also gone. Then you have over here, they can vote for Qureshi. They can also vote for this. But if they vote, for example, suppose I put a click over here. This is 4 votes from here. Okay. So this is 4 votes from here. There's 1 vote. This is 5 votes done. Where will the 6th vote come from? Can it come from here? No, because all of them have to vote together. So again, I am left with a kind of a quandary. Then this 1 vote will have to come from here. So it is a possibility. So I will not mark it off now. Over here, can he vote for this department, vote for somebody who has gotten a total of 1 votes? And essentially, if this is total of 1 votes, nobody has voted, else no other department has essentially voted for Samuel, because this 1 vote is from Qureshi and that is now accounted for. Now consider for Samuel it is done. for Pakrasi, who could the votes potentially come from? So I have put cross, cross, cross. From all other departments, it is a cross, which means that the 2 votes that are required for Pakrasi have to come from over here, which means that this is not 1, 2, 3, this is exactly 2, which means that from OQ, you have 1 candidate from OQ, from BNH also you have exactly 1 candidate, because there are 2 remaining votes from this particular this. So there is exactly 1 candidate from BNH, there is 1 exactly candidate from O and Q. So this is done, this is therefore this remaining will be crossed, BNH cannot vote for anybody else. Now consider the situation. So if I consider, say that these 4 people voted for O and Q, 4 people voted for, say this is a total of 5, okay. This is a total of 5, so I'll need 1 more vote. Where will that 1 more vote come from? Because the only person remaining are these 5 to 7 votes. They are not going to split and give 1 vote here and the remaining vote to Qureshi, right? So that means this 4 is impossible. So even here I can put this cross off, which means that the 4 that I require or the 5 that I require has to come from here directly. Only way I can get 5, because here at max I can give 4 and I can't get 1 off from another department. So all 5 have to come from M. So that means that M department has, that is M&S department has 2 people. There are 5 non-candidate votes and 2 candidate votes. So which means that M&S department have 2 candidates, O and Q has 1 candidate, B and H has 1 candidate as such. So essentially let's consider M&S has 2 candidates, O and Q has 1 candidate, B has 1 candidate, which means that F department has 0 candidates as such, which means that all 9 votes are going to go for this person. There is no candidate from F and H department, so all 9 votes will go for Qureshi. Now Qureshi needs a remainder, so 1 vote from here, 9 votes from here, total of 10 votes. So the remaining 4 votes will come from the O and Q department. So we have been able to figure out where the votes are coming from, but we have not been able to figure out who is from which department. That is the last thing left to figure out. How do we figure that out? We have to use the fact that you cannot vote for the person from your own department as such, and 2 people are from the same department. So how do I figure that out? So basically, let us figure out who is from F department, who is from M&S department, who is from O department, who is from B department, and who is the which candidate is from which department as such. So there are 2 candidates from M&S. So let's consider who can be these candidates. See, I know that Pakrasi received 1 particular vote from Samuel. So P and S are not in the same department. So not in the same department. Q voted, got a vote from Ramaswamy. So Q and R are not in the same department. R got a vote from P. So P and R are not from the same department. Okay. And S got a vote from Q. So Q and S are also not from the same department. So basically, if I look at R and S are not with P and Q ever as such. So P and S are not together, P and R are not together, Q and R are not together, Q and S are not together. So essentially, it could be that either R and S are in the same department, or the 2 people who are there in MS department, essentially it could be RS or PQ. So it can't be PR or PS as such, it has to be either PQ. And similarly, it can't be QR or anything else. Either it is PQ or RS as such. So the 2 people that are there from this, there are 0 from F and O. So I can directly tell there are 0 from F and O. So this can be either PQ or it can be RS as such. Because if I can see, these 2 are definitely not in the same department as such. Now who received the M&S department votes? R received the M&S department vote. So R is definitely not from the M&S department, which means that RS cannot be the possibility for M&S department. So M&S department is PQ for sure. We had PQ or RS as possibility because P and S are not together, Q and R not together, P and R are not together, Q and S are not together. So PQ is one possibility, RS is one possibility. So these are the 2 possibilities. M&S department, you need 2 candidates. So those 2 candidates could be either PQ or RS, but R received votes from the M&S department, and the rule says that you can't vote for the candidate from your own department. So RS is not the possibility. RS can be eliminated. So the 2 candidates from M&S department are PQ. So that I have found out. Now R and S are over here. So either it could be R over here or S over here, or this is S over here, R over here. Now I'll do a final check whether who voted for whom. So P got a vote from behavioral department, which is fine because he's from the MS department for sure. Q got the vote from O and Q department, which is also fine because he's from an MNS department for sure. O got the vote, so R got the vote from MNS department, which is also fine. because he is from the OQ department or B department, which is also fine. S got no other votes, so that is also fine. Let us consider the P voted for S, which is fine, he is not from the same department. Q voted for, S voted for P, which is fine because they are not in the same department. Q got a vote from R, again not from the same department. R got a vote from P, not from the same department. S got a vote from Q, again not from the same department. So this is basically the final possibilities, considering all the rules, all the possibilities. I know that from the M and S department, P, Q are there for sure. R can be in the O department, S can be from the B department, or vice versa as such. This is the final configuration of who got what votes and who is from which department. Now let's take a look at the questions. Which two candidates can belong to the same department? So I can tell for sure that P and Q are from the same department. So correct answer is option A. The second question is, which of the following can be the number of votes that Qureshi received from a single department? So from a single department, Qureshi received 9 votes and 4 votes. R can be from the O department. So basically total from O department can be 4 or 5 as such. If R is from O department, it is 5 votes. If R is not from O department, it is 4 votes as such. So the possibility is 9 votes, 4 votes or 5 votes as such. That is the possibility. Of the options, only 9 is the correct answer. So correct answer is option D. The third question is, Professor Samuel belongs to B and H. Which of the following statements is true or false? So if Professor Samuel is from B and H, so that would mean that this possibility is removed. Professor Samuel is from B and H, R is from O and Q. So these are the final cases as such. So let's take a look. Professor Pakrasi belongs to M and S. This is true. In all cases, Professor Pakrasi has to belong to M and S. So this is definitely true. Professor Ramaswamy belongs to O and Q, which is also true. This is also true as such. So this statement is also true. So both statements A and B are true. So the correct option to choose is option D. What best can be concluded about the candidate from O and Q? So here I cannot assume the information from the previous question. So the candidate from O and Q is either R or S. So that is what can be concluded. So it was not Samuel, not necessarily. It can be Samuel or Ramaswamy. It was either Professor Ramaswamy or Professor Samuel. This is the correct answer because it is either R or S as such. So the correct answer is option B. The last question is, which of the following statements is or are true? Non-candidates from MNS voted for Professor Qureshi. Non-candidates from MNS voted for Ramaswamy, not Qureshi at all. So this is untrue. Non-candidates from FNA voted for Professor Qureshi. This is true. Non-candidates from FNA did vote for Professor Qureshi. So only B is true. So the correct option to choose is option B.
We at Cracku provide all the previous year CAT papers along with many other MBA examinations such as XAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.